So I'm just giving a very brief introduction to Unix command line and virtual machines. Uh, Lisa will give you some of the background to what CLIMB is, but what we use in CLIMB are virtual machines, but they don't look any different to a normal server to the user, really. So, what's Unix? Unix is an operating system, computer operating system, and I don't think it's much of an exaggeration to say that Unix now runs the world. So all of you have got iPhones, or you're running Unix on your iPhone, a variant thereof. All those on Android are also doing the same. It's a very pervasive operating system. Only these Windows machines are sort of bucking the trend of having Unix, because Unix underlies the Mac operating system as well on Mac computers. So it runs on many different kinds of computer servers, and it has this ability to provide a multi-user, multitask environment. So it means that more than one person can use that computer at the same time, and they can be doing more than one thing at the same time as well. And it keeps all the various parts of the computer working together, orchestrating what they're doing. It has basically three parts: the kernel, which is the part that all your various commands interact with, and sometimes you get this rather kind of colourful expression, kernel panic, when the kernel of the Unix system is upset and suddenly the whole machine crashes. Then you've got various programs and services, and you've got some configuration files that are needed by the system to run. So this is a very complex thing. I just stole it from the Wikipedia article on Unix, but it just basically shows the evolution, descent with modifications applied to Unix operating systems. So you started off back long time ago, back in 1969, where you started with a version of Unix that spawned out other variants, and so it happened. So we've got there at the bottom there Macs running on Unix. So the Mac OS X is running on top of Unix. Android phones running Unix. CLIMB, our whole cloud computing system, runs on Unix. Basically, this is the system that is running the world. And it's a bit strange, you know. This is a rather quaint old system from the 1960s and 70s, but nonetheless, it has not been replaced by anything better or comparable. So one of the things we have to do when using Unix, certainly to the full, is we have to make use of the command line. And so many people are used to using computers. They go and use a word processor, or load their photographs or whatever. But they're using a graphical user interface where you can grab hold of things, you can move them around. You've got windows there, you've got a mouse. And that graphical user interface has got many advantages. It is intuitive and easy to use, but it doesn't give you the same power and versatility as using the command line. And it's quite hard to write good programs that will run a graphical user interface as well as and do other things that you want to do as well. And that means that there's a lag time in development. It takes a lot longer to get a program running that you can use on a graphical user interface. By contrast, the command line, there is one problem, which is that you do have to remember the precise commands that you use, the precise letters and other characters that sit in those commands, and usually the operating system is completely unforgiving. If you make a slight mistake, it will just not work or give a load of grief. But it is very powerful and versatile, and it's easy for people to write code to write programs. It's also very easy for people to write scripts so that they can join various programs together into pipelines. So you can take the output of one program, easily feed it into the next program, and so forth. And so if you want to work at the cutting edge of bioinformatics, and you want to actually use the most up-to-date programs, the most powerful programs, you do have to use the command line. Why are we still sticking with Unix? well, it's good for automation of these computer tasks, and you can really set off huge complex analyses with just a few keystrokes. So you want to analyse 1,000 genomes, you can just put in one command, and it will just go off and do it. You know, contrast that with having to manually pull files around on a graphical user interface or whatever. And it's very good for actually pattern matching as well. You can search through data and manipulate text files very easily. And in that sense, it's very fast. Now, you may have come across the term Linux. Linux is a variety of Unix, which is free and it's open source, so you can see how it's put together. And it runs on all PCs and Macs, and even on mobile devices, you can get it to run. And over the last 20 years or so, it has become the kind of industry standard for people working, creating scientific software, particularly scientific software that's created by academics to be used by other academics, where people aren't trying to make money out of it necessarily or come up with something polished. They come up with something that works straightforwardly, and they make it available for Linux. So when you want to interact with Linux, you have this command line interface where you type in the commands on the computer and Linux will execute them using what's called a command shell. So there's a program that interprets the commands you have, that you put forward, and executes them. And there are various different kinds of shells that you can use, and there are just minor differences in their behavior. Some of the commands behave slightly differently. A common example is one called bash, which is some kind of poor pun on born again shell. Some bioinformatician was trying to make a joke some years ago, I guess. But bash is a very common one that you'll see. I'm not sure, are we going to be going into bash when we go? We are. So one of the things that is slightly frustrating, but it also gives you power to some degree, is that the Linux commands are case sensitive. So if you type in exit with a capital E, it's treated as a completely separate thing from exit with a small e. So if you name your file exit.whatever with a capital E, and then you try and execute a command on it and you don't capitalize the E, you just won't get anything done. And similarly, bow tie with a capital letter at the start, and then all lowercase is not the same as all uppercase, bow tie and gate. The other thing, if you've used Windows before, there's just a slight difference here that you use a / here as a way of separating directories when you're giving out file paths, unlike Windows. And Linux file names here, there's a bit more, for those, certainly those who use MS-DOS in the days, the Linux file names are a little bit more descriptive, a bit more flexible. You don't actually need a file extension, although most of the time people do put a file extension onto the file names. So there's some more flexibility there. So when you're using Linux, you're working with the applications and with the files, and there are different file types. So you've basically got the difference between a text file, basic files, text, or binary type files, which are sequence files, and then you've got executable files, which are programs, which are binary files that you can actually make run a program, run as a program. Now, one of the very useful features of Unix commands is that they have the same basic form. So you issue the command with the name of the program usually, and then you have a variety of options, and those options are often, they start usually with a hyphen at the beginning, and they're sometimes called flags. And then you have some various arguments as well, like what is your program actually going to work on? So what files is it going to work on, or what directory or whatever. So here is an example where ls -l and then /temp. So ls is a command. It basically lists the contents of a directory, and it's modified by here we've got this -L, which I'm trying to remember, that stands for long, doesn't it? So it gives you a longer output than if you just typed ls. It gives you a much longer description of the files, and then /temp is the argument as to the directory there. When you set a program running, sometimes you decide actually you didn't want to do that, or it's taking too long or whatever, and you can just abort that. You can, combinations like Control-C or Control-Z will often just stop the program in its tracks. The Linux file system, there's this hierarchical kind of tree structure, and you can write the path, describe the path, which is the route to where your files are, in two ways. You can have a relative path. So if you're in the, say, in the admin directory here, you can just call that directory Steve, just call it Steve, and not put anything else there, because the programs will often recognize where you are and actually just know that. But the alternative is that you can actually write the absolute path, which is, so basically right at the top of the hierarchy, you've got the slash there, you've got kind of root at the top, and then you go from there to users /admin/Steve as a way of specifying it. You can run Linux on your own computer, your personal workstation, laptop or whatever, but often it's run on a server where there are multiple users. To interact with the server, you'll need the username, the password, and the server name, and that's typically an IP address as a way to actually get there. On the Mac, you have there's a program called Terminal that comes as part of the Mac operating system. On Windows, you have to install a program called PuTTY to allow you to get access to a remote server. And when you do this remote login, you're doing it through the command line, and it means you may not be able to see graphics or interact in any kind of graphical way. You can generate graphics files and then download them, but you'll not be able to see what they look like purely through this remote login on the command line. Now, we also, on our cloud computing system, we have a series of virtual machines, and they're all running Linux as the operating system, and that's what you will be logging into. So as far as you're concerned, it won't look as if you were any different from if you were logging into just any old remote server. The fact they're virtual machines doesn't matter. But just to make clear, what is the cloud all about? Well, basically, there's me standing next to some of our servers in Birmingham. That was. You've got many servers, much storage. One of those servers, a user wants to use that, and so they'll spin up what we call a virtual machine, which is effectively a sort of self-contained module that contains the operating system and some software, and it's kind of slotted into one of those servers. So this individual might only be using a quarter of the capacity of that server, of the real server, to run their own virtual machine, their own virtual server. But that means other users can come in and start using other chunks of the available hardware. And this gives a kind of flexibility in the way in which hardware is used that brings benefits. So in the CLIMB project, we have a way of actually launching virtual machines on our setup. So what you can do as a user is you can say, oh, I want to have a server. And we allow you to go in there and just start a server. So it basically starts some software running which creates a virtual machine. It gives you an IP address so that you can then log into that virtual machine as a Unix user. But we're not going to do that today, but we also do allow people to customize the machines that they want the virtual machines that they want to launch. So you can change the specifications somewhat as you wish. So these are the groups running here. So this is brin.climb.ac.uk. It's just a site that we have set up ourselves to make a user-friendly interface for people to use. That's me finished giving a little brief, quick run-through of Linux command line and introducing to the idea of virtual machines. Lisa will give you a talk later a bit more about CLIMB the project and just basically